All right, so welcome to Module 2 of Programming in C Sharp. Up to this point, we were doing long lectures, but what I'm actually going to start doing are short lectures. So today, in this very short micro lecture, what we're going to discuss is declaring variables. So let's talk about understanding variables and the way they work. So what are variables at their most highest point? Well, you have different types, right? You have constants. Now, constants are variables that we declare that cannot be changed after the program has been compiled. I will say that again. A constant is a variable which we declare that cannot be changed after the program is compiled. Now, there are certain situations where constants are desirable. Constants are extremely desirable when we know our values will never change. For instance, math.py. Math.py in the math library is a constant. It is a public constant. We can actually pull that specific property, that specific variable assigned value of 3.14, whatever the rest of the numbers are, up to the 13th digit, right? We can pull that out every single time when we use the math library. You can use the math library the same way you use the system library, right? You use it as a namespace and pull it in. Math.py is a constant, which means that when your program is compiled and or the library you are using is compiled, it cannot be changed. Which means that if you have constants in your code which are immutable, we're going to use that word now. We're not going to use the word cannot be changed or the phrase. We're going to use the word immutable. Immutable means that it is not mutatable. It cannot be changed. So a constant is a variable which has been assigned a value by the program when the program is compiled, which is immutable. Okay. A literal constant is a value taken literally at each use. It's almost like a string, right? A literal string or a string literal is a literal constant. Now, why is a string a literal constant? Well, because strings are, here's that word again, immutable. They cannot be changed once you create them, just like arrays. Arrays are immutable when it comes to the length of the array. Once you define the length of the array can no longer be mutated to have less or more positions. Now, there's a way around this. There are situations where we want to update the immutable string, right? The string literal, we would like to change it. Well, in order to change a immutable object, you have to create a new object, which means that if I want to update a string, meaning I want to remove a character from the string, or I want to add a character to a string, or I want to combine two strings together through the process called concatenation, we're going to get into this in another micro lecture, what I need to do is I need to create a new string, which means I would need to declare a new variable, or I would need to assign the value of that new string to the variable that I'm already using. Talking about variables, what are variables? Variables are named locations in computer memory. If we were using C or C++, you would actually need to call a pointer or reference to get that specific memory location out. It is more akin to assembly than it is to high-level language, but C++, for all intents and purposes, is an OOP language. So we're going to keep it within the same wheelhouse as C# and Java. But a variable is a allocation of computer memory that can hold different values based on what you want that value to be. Now, the word hold is very strong, so we're not going to use that word anymore. We're going to use the word assign. We're assigning a value to that variable, or we're assigning a value to that memory location in your random access or static memory. Okay, what's a data type? Well, when we have a variable, there's different types of data you can save to a variable, but it's very important that the variable understand what it is supposed to be, what type it is supposed to be, what role it is to play. So, for instance, in our last video, you saw I use the keyword var, V-A-R, to denote the type of data that that variable can hold, which basically means you figure it out. Now, in programming, there are two types, all right, of data typing. There are two types of data typing. The first type is loosely typed. Loosely typed data types or loosely typed languages are languages where you don't necessarily need to tell the language what data type it needs to be when you're defining the variable. Okay, so in the case of C#, C# is a mixture of loose and strict, meaning you can define the data type explicitly, meaning you manually say, I would like you to be string and your name will be message. Or you can say var message equals, and then whatever the outcome of what's on the assigning side of the equation, whatever that data type outcome is, that is what the new variable will assume. Now, this loosely typed development allows for a more dynamic development environment where you may not get back a string. You may get back an integer. This allows for less exceptions at the programming level and more fluidity and dynamics. What it also does is it can increase the amount of exceptions handling at the database level if the database itself does not know explicitly. The word explicit is very important here. The database or the data layer does not know explicitly what type it is supposed to have, because at the database level, it's always strict. We've yet to figure out specifically how to create a loosely typed environment that is understandable, usable, and adheres to relational databases that we all agree is the most efficient. Big data be damned. We can talk about big data. That's a different conversation altogether. And when you do that, you still have to traverse the node and all this other stuff. In this situation, I'm speaking specifically about a relational database management system, RDBMS. So the last slide I want to show you is three more things that might give you some more context. You have intrinsic types of variables, which are built-in data types. We call those primitive types. Those primitive data types, you'll also hear the word primitive in the sphere of Java, but primitive data types are exactly what they sound like. They are normally built into the language, and they are the root data type you can use. You can build your own data types. We call these classes, okay? And those classes can be instantiated as objects, and those objects can be treated as data types. But for all intents and purposes, all data types which are primitive already exist in the system namespace. Those which we commonly refer to as primitive are as follows. Lowercase int. I'm making that delineation because there is an uppercase int. Uppercase int is not primitive. Lowercase int is primitive. Double, decimal, char, lowercase string, not uppercase string. Uppercase string class is not primitive. Lowercase string class is primitive. Notice I'm using air quotes here. Is primitive. It is primitive in C#. Just understand that strings are not primitive. You can treat a string as primitive. Strings are one of the most dynamic data types that we have. We use it for almost anything. It can be used for almost anything. Any other data type can really convert to it and convert away from it. It is one of the most wonderfully dynamic data types out there, but it is not primitive. From the perspective of C, C++, and Java, strings are an array of characters. We're going to get into this when we talk about strings. I'm going to have a whole micro lecture on that. Just understand that strings themselves are not primitive, but within the context of C#, C# treats it like it is primitive because it also has a custom class uppercase string, and then Boolean. So Boolean is true or false. We use the Unicode system within C#, which is the same across the board when it comes to languages used both at the SQL, NoSQL level, at the high level or high language level, and the scripting language level. They all use Unicode. So Unicode is the source of truth. There is a data type that's not annotated here, which is the bane of all of our existences, and that's datetime. We're going to talk about datetime, but I don't know if we're going to talk about it in module 2. But datetime is also a data type which can be very difficult to deal with, but it is very important. Either way, that's all I have for this. So let's pop on over to REPL, if I can get to it. I wonder where I hid that. I'll pull up a new REPL, I guess. And let's do some development really fast before we pop away and get another micro lecture under my belt. All right, so this is our old this is our old iteration of what we built in the last module. And what I want to do is I want to enumerate, or I want to iterate over what we just discussed. All right. So for that reason, let me. All right, great. So we talked about a constant. Let's create a constant. All right. Normally, when you create a constant, you want to create a constant outside of your method. All right. So in this case, I would say private static, because we're within the main class. I have to stay static. Private static const equals, and then I will give it a name. My const equals 1.0, and there we go. Now it is mad about something. Let's find out what that is. Type of namespace my const. Can't do this. I wonder if that's the problem. Right. 1 second. Just to make sure I'm using this right. I could theoretically, yeah, that's right, and give it a data type. We'll say double. And this looks happy now. Const cannot be marked static, and that's totally fine because it can only be 1. And there we go. Now, what's going on at line 4? At line 4, we have a couple of things going on. Let's discuss it. So we have my access modifier, which is the private. I want only this class to be able to access this constant. I also have the word const. This is the shorthand for const. And then the data type that I want to use. In this case, I'm using a double. I know I have not explained what doubles are, but just understand that doubles are integers with decimals. They're basically decimal numbers, okay? Integers are numbers without decimals, and you can tell it's a number because there are no double quotes around it. Double quotes delineate that we're using a string literal. No double quotes and numbers delineate that we're using integers or doubles. Now, you can look at it from 2 perspectives. Either we're using an integral data type, integers, which is no decimal point, or we're using numbers with decimal points. That's double, long, float, decimal. Don't quote me on decimal, but I know it exists. Either way, if I want to declare my variable here, it is very important that I not only declare the variable as I did on the left side of this equal sign, but on the right side of the equal sign, I assigned it a value. All right. So I declared the variable on the left side of the equal sign, and then I assigned it a value on the right side of the equal sign. This is called initialization. This is the best practice for declaring variables because you do not want to declare. Remember from our PowerPoint, what is a variable? It's an allocated space in memory. You don't want to allocate space in memory that has nothing in it. Right? What that actually does is it creates a situation where the program says it's using a specific amount of memory, but like 50% of it or whatever variables are not filled with values, that's empty. You basically just allocated empty space to your program, and that's not efficient or judicious when it comes to using memory within your program. So it's very important that we don't do that. When I am declaring const outside of my method, I need to define the access modifier. But if I'm declaring this inside my method, I actually don't have to do that. I can just say const. Yeah, it's there. Now, notice underneath here, there's an orange or a yellow squiggly line. That just means I'm not using it. All right, this is another nice feature of Visual Studio and REPL. It'll tell you when you're not using the variable. But either way, notice something else. Notice at line 9, when I declared that variable, I declared it using what's called camel case. That means that the first word is all lowercase. And then the second word and every subsequent word after that, the first letter of that word is capitalized. Well, at line 7 and line 4, the name of my constants are all capitalized. Now, that's very important. Not only are they all capitalized, but they're all capitalized, and each space is delineated with an underscore. Notice here, full name has no underscore between full and name, but another const does. This is just one of the different ways that we define the names of our constants so that within the code, we know what we're looking at. Because if this was 500 lines of code and you saw that another underscore constant, you immediately would say, well, that's all uppercase with underscores in between. That has got to be a constant. So let me go find out where that is. Okay. A literal constant is what you're looking at here. The string literal right here, that's a literal constant. That means you have a constant that's defined by the literal use that it's using with the parentheses. All right. And that's really it. There's nothing else to talk about at this point other than the fact that there's another micro lecture right after this one. So stay tuned. And as I say in all my videos, lectures, and whatnot, good luck. Have fun. Ciao.